Among the sauropods, the often colossal, long-necked herbivorous dinosaurs that first appeared throughout the early Jurassic, several stand out as some of the most iconic and well-known. Take, for example, Brachiosaurus, one of the tallest and most unique sauropods. Or perhaps Argentinosaurus, with its astounding size. Or the iconic and universally known Brontosaurus, the most well-represented sauropod in the media. All of these dinosaurs are very different, but all of them stand out for their massive sizes and unique place in the media. One more sauropod, however, stands out from the crowd, for not only its awesome size and media representation, but for its formidable weaponry. Diplodocus was a late Jurassic sauropod that boasted a terrifyingly powerful tail, one that could have been used to protect itself from some of the largest and toughest predators of the Jurassic. In today's video, we will be exploring the life and history of Diplodocus in close detail, examining exactly what made this amazing tail so special, where the dinosaur lived and how it was discovered, amongst other features of its incredible existence. Sit back and relax as we take you back to the late Jurassic to explore Diplodocus, the dinosaur with a whip for a tail. Diplodocus was a huge late Jurassic sauropod that lived between 154 million years and 152 million years ago in what is now the Midwestern regions of North America from the incredibly fruitful Morrison Formation, one of the most well-known regions of the Jurassic. Diplodocus fossils are very well known from the Morrison Formation, and the dinosaur is one of the best represented sauropods in the fossil record, full stop. The dinosaur is perhaps one of the most easily identifiable sauropods, with its horizontally held neck and tail, both of which are incredibly long in comparison to its body size. Like all sauropods, Diplodocus was well known for its colossal size, which was supported on 4 legs, its body balanced by a long neck and even longer tail. There are 3 known species of Diplodocus: Diplodocus longus, the type species, as well as Diplodocus carnegii and Diplodocus halorum. Diplodocus carnegii is one of the longest known of all dinosaurs, a complete skeleton of which has taught scientists that it may have measured as much as 26 meters from head to tail. Estimates on the weight of Diplodocus carnegii have suggested that it could have weighed as much as 14 metric tons, over twice the weight of an African elephant. There is evidence that Diplodocus halorum could have been even bigger, but this species is only known from fragmentary remains, so a complete size estimate can't be made accurately at this time. The man who discovered this species, David Gillette, an American paleontologist, has even suggested that his discovery could have measured anywhere up to 52 meters in length, which would have made it the longest animal species in the fossil record. As it turns out, it is thought that David misplaced some of the vertebrae when calculating this, and in reality the dinosaur is thought to have measured between 29 to 33 meters. Diplodocus carnegii was used in the size estimates for Diplodocus halorum, and a specimen which now sits on display at the Carnegie Museum of Natural History in Pittsburgh, Pennsylvania, was studied extensively in the calculation process. To a time traveler lucky enough to find themselves in the late Jurassic, the first noticeable feature of Diplodocus would have been the almighty lengths of the neck and tail. We will cover more information about the tail in the next segment of this video, but it can't be ignored here. It is the defining feature of this massive sauropod, and one that would have acted as a great counterweight for its huge neck. In Diplodocus carnegii, the neck is estimated to have measured on average 6.5 meters in length. This is over double the neck length of that seen in the world's tallest giraffe, which should give you an idea of just how large some of these dinosaurs were. Scientists are unsure, however, whether any of the skulls that have been dug up and assigned to Diplodocus actually belong to Diplodocus. Diplodocus lived in an environment populated with other closely related dinosaurs, and from skulls that certainly belong to these other animals, scientists have been able to more or less accurately reconstruct the skull of Diplodocus, even if the skulls they've found already don't belong to the right dinosaur. Diplodocus's forelimbs ended in drastically modified digits, which had fused together to become a vertical pillar, flat on the bottom and horseshoe-shaped. Only one claw was present on the innermost digit, and this was much longer than claws found in most other sauropods in this position. It is unknown what the purpose of this claw might have been in the daily life of this dinosaur. It might surprise you to know that we know a lot about Diplodocus's skin, based on partial skin impressions that were found in the Morrison Formation rocks in 1990. The skin impressions showed that Diplodocus was covered in a row of narrow spines, which ran down the length of its back as well as the neck and tail. The longest of these spines were around 18 centimeters in length and were possibly used for display or defense. The skin known from Diplodocus shows several different types of scale too. Polygonal scales sit adjacent to rectangular ones from the limbs. Oval-shaped scales from the back are interspersed by dome-shaped scales, and so on. A great degree of scale diversity is present in a relatively small area of skin, implying that these skin impressions might have belonged to a young member of the species. Studies on the scleral rings around the eyes of Diplodocus indicate that it might have been a cathemeral animal, much like modern-day big cats or primates. This means that they were active at irregular short intervals throughout the day, perhaps sleeping at different times throughout the course of a 24-hour period. It was also once thought that due to the position of the nasal openings on the top of the skull, rather than the front, that Diplodocus was aquatic, using the top of its head like a snorkel to help it remain under the water while it could still breathe. However, this was disproved when it was calculated that the water pressure on the animal's chest and lungs would have prevented it from breathing. Diplodocus was, in reality, firmly terrestrial and fed on ferns and bushes close to ground level. It may have temporarily entered the water to bathe or drink, but the majority of this huge sauropod's life was spent safely on dry land. These dinosaurs supported their massive weight with oxygen by breathing in the same way birds do, a much more efficient system than most mammalian and reptilian lung systems. While Diplodocus was a quadrupedal animal for most of the time, it would have been able to rear up on its two hind legs, effectively using its massive tail as a third in order to reach the branches higher up in the tops of the trees. This would have allowed it to exploit new food sources when ground-level plants were sparse, allowing for more versatility and adaptability in the face of an ever-changing natural world. An extra 11 meters would have been added to the dinosaur's height when feeding in this manner. Diplodocus is also thought to have employed the usage of nesting sites or creches, where many baby sauropods were laid in eggs in the same place. Shallow dips in the ground would have been carved out of the earth with the dinosaur's forelimbs, and the eggs would have been deposited within. Diplodocus eggs, like many other sauropods, would have been tiny in comparison to the size of an adult, and when the babies hatched, they would have been unrecognizably small. It is thought that they may have teamed up together in small herds of young sauropods in the woodlands as they grew, until they were large enough to join a herd of adults safely. Let's move on to the most notable aspect of Diplodocus's body, that impressive, immensely long tail. Almost every piece of dinosaur literature surrounding Diplodocus and its mighty tail typically describe it as whip-like, and with good reason. A typical Diplodocus tail might have measured up to 12 meters in length, weighing around 1,500 kilograms. A whopping 82 vertebrae would have composed the tail, making it a flexible and maneuverable tool that would have proven invaluable to a fully grown adult. Until very recently, it was thought universally that Diplodocus's tail, when cracked like a bullwhip, would have been able to travel as fast as the speed of sound, creating a lashing, snapping sound as it broke the sound barrier, similar to a real whip. In order for Diplodocus to break the sound barrier, the end of its tail would have needed to travel about 761 miles per hour, an insanely fast travel rate. This belief was the norm since studies on Diplodocus's tail were first undertaken. However, a much more recent study, undertaken by Simone Conti, a doctoral student in aerospace engineering and paleobiology from the Nova School of Science and Technology in Lisbon, Portugal, was published in the journal Scientific Reports on December 8, 2022. Simone's studies provided evidence that Diplodocus's tail was not equipped to break the sound barrier, but could still travel impressively fast. The once proposed 761 miles per hour was cut down to a subdued but still very fast 62 miles per hour, roughly the speed limit for vehicles traveling on the motorway. In order to reach the claim, Simone and her team studied 5 separate specimens of Diplodocus and dinosaurs closely related to Diplodocus. They were able to create a digital model for the animal's tail using the fossils they studied, which can provide scientists with a reliable simulation of what the tail looked like and how it may have acted. Using the digital modeling software, the scientists attempted to get the tail to break the sound barrier. In its attempt to do so, however, the tail smashed itself under the pressure of having to produce such incredible speeds. In real life, if a Diplodocus tail attempted to break the sound barrier, then it would have broken nearly all the vertebrae in its tail. This would have resulted in an eventual loss of balance, resulting in the animal becoming an easy target for predators and an eventual meal, if it didn't struggle itself to death first. The scientists determined that the soft tissue in the vertebrae could not stretch far enough to accommodate the pressure on the bones, which resulted in the tail being smashed into several pieces on the digital simulation. Similar methods have been used to test the stress on aeroplanes to ensure that they do not sustain damage during flights, but this technology is rarely used on dinosaur remains. The tail of Diplodocus has always been compared to a whip, both in form and function, but in reality we don't have a definite answer on how the dinosaur used this formidable tail. One of the most commonly cited uses for the tail is that the dinosaur used it not only for balance, but as a vicious whip to slash and lacerate the skin of attackers. Diplodocus lived in a world full of formidable predators, dinosaurs such as Allosaurus and Torvosaurus, which were large, aggressive theropods that would have likely taken young or injured Diplodocus when the chance arose. To combat these ever-present threats, Diplodocus may have employed a strategy of pulsating the tip of its tail, lashing it around like a coach whip. While the speed estimate of the tail has been greatly reduced, a long and thin structure measuring over 12 meters long and traveling at over 60 miles per hour would have certainly been enough to cause lasting damage. A tail traveling at such speeds would have caused searing cuts on the skin of an assailant, which, depending on the size of the dinosaur, could have been lethal in extreme circumstances. This would have certainly been enough to ward off an attacker if the sheer size of the animal didn't do the job in the first place. Another possible use for that monstrous tail is far less violent. Some scientists have proposed that Diplodocus may have used its tail as a means of communication, perhaps to signal to other members of a herd, or to attract mates with dazzling, whirling displays. Perhaps if a hunting party of Allosaurus were spotted on a hillside, a lookout Diplodocus could have waved its tail in accordance with a certain vocalization, warning the herd of the impending danger. This would have given the dinosaur enough time to get themselves into a defensive stance before it was too late. In mating rituals, these dinosaurs may have rapidly spun their tails, waving them in intricate patterns and shapes to attract the attention of mates. This is all speculation, of course, based on the opinions of scientists, but it is a fun exercise in paleontology to consider what a Diplodocus communication display might have looked like as they waved their tails at the speed of cars traveling down a motorway. Diplodocus was one of the many dinosaurs unearthed in what has become known as the Bone Wars, a petty feud between paleontological rivals Othniel Charles Marsh and Edward Drinker Cope between the 1870s and 1890s. The first known Diplodocus specimen was discovered in a quarry at Garden Park, close to Canyon City, Colorado. These were first dug up by the paleontologists Benjamin Mudge and Samuel Wendell Williston in 1877. This first Diplodocus was composed of 2 vertebrae from the caudal region of the backbone, along with a few other bones from adjacent parts of the body. The remains were sent to Othniel Charles Marsh at the Yale Peabody Museum of Natural History. Marsh named the dinosaur as a new sauropod species, Diplodocus longus, meaning long double beam in English, a reference to the vertebrae on the middle section of the tail, bearing 2 structures known as chevrons on each bone. In hindsight, it looks as though Diplodocus longus might be a dubious species, and there have been recent efforts to rename Diplodocus carnegii, a more closely known dinosaur, as the official type species of the genus. Further notable discoveries came after the Bone Wars, when Marsh and Cope had ceased their bitter rivalry in favor of starting their own fossil collections. A crew of paleontologists from the Carnegie Museum of Natural History in Pittsburgh, Pennsylvania, headed out to the Morrison Formation in Wyoming in 1899 with a view to learn more about the dinosaurs that lived there in the Late Jurassic. They were lucky enough to unearth a near-complete and very well-preserved specimen of a new species of Diplodocus. A year later, another skeleton was found preserved right next to the first one. Both of these Diplodocuses were studied and officially described by paleontologist John Bell Hatcher in 1901, who officially named the dinosaur Diplodocus carnegii after the Carnegie Museum of Natural History. In 1907, the museum would go on to create a mount of the dinosaur skeleton, using other known, similar dinosaurs to fill in the gaps of the bones that were missing. This specimen was nicknamed Dippy and has since gone on tour around the world, having been displayed in various different museums. Dippy has been displayed at the Natural History Museums in Berlin, London, Paris, St. Petersburg, Madrid, Buenos Aires, and Mexico City, amongst others. This was the first time a sauropod had been mounted and put on display outside of the United States of America, and served to bolster a worldwide interest in paleontology amongst the general public. One of the most complete Diplodocus skeletons unearthed to date was discovered in 1923 at the Carnegie Quarry, close to what is known as the Dinosaur National Monument in Utah. This was a specimen of Diplodocus halorum, the largest of the known Diplodocus species. It was initially assigned to the species Diplodocus longus, but the differences, especially those concerning its sheer size, led those studying it to reclassify the dinosaur. It is currently mounted at the National Museum of Natural History in Utah. From here, Diplodocus specimens became rare for many years. That is, until 1979, when several vertebrae were discovered by 3 hikers near San Ysidro, New Mexico. The nearby New Mexican Museum of Natural History conducted an expedition to unearth the dinosaur, led by David D. Gillette in 1985, and the fossils were eventually excavated and taken to the museum. It was initially presumed to be a specimen of Seismosaurus hallei, but when Diplodocus and Seismosaurus became synonymous in 2006, it was moved to the species Diplodocus halorum. In later years, from 1994 onwards, the Mother's Day Quarry in Carbon County, Montana, has become a very important site for the discovery of Diplodocus. This site was studied by paleontologists from the Museum of the Rockies, who discovered a series of Diplodocuses of different ages, from young to adults. These fossils were immaculately preserved and have resulted in the discovery of the skin impressions we covered earlier. It remains one of the most important paleontological discoveries of recent times. Diplodocus is most closely associated with the parts of the Morrison Formation that coincide with coastal areas, where the sediments are rich in alluvium. Shallow seas would have sat adjacent to open plains and dense woodland, forming a semi-arid environment that harbored a wide range of dinosaurs and other prehistoric life. As the precursors to the Rocky Mountains began to crop up in the environment, rivers and lakes would have formed, giving way to wetlands and swampy regions in the lowlands. The region is known for distinct wet and dry seasons, and it is likely that many animals would have migrated between different parts of North America when the dry season came around. Diplodocus's range is thought to have covered much of what is now the United States of America, as well as some of the southern reaches of Canada. Many of the most famous dinosaurs from the Morrison Formation were sauropods, and nowhere else has such a high concentration of these spectacular animals been unearthed in such close proximity. Diplodocus would have lived on the open, arid plains alongside dinosaurs such as Apatosaurus, Brachiosaurus, and Camarasaurus, some of the most recognizable and well-known sauropod dinosaurs of the entire Mesozoic. It is unknown what some of the interactions between these species may have looked like, but they must have been awe-inspiring, without a doubt. Weaving in and out of the pillar-like legs of the sauropods would have been a slew of smaller ornithischian dinosaurs, most famously the herbivorous bipeds Othnielia and Dryosaurus. These dinosaurs may have intentionally followed sauropod herds as they kicked up the earth with their massive footprints. As they walked, they would have turned up grubs and other invertebrates, which may have been ideal supplements for these little herbivores. Other ornithischians from the region include the world-famous Stegosaurus, the early ankylosaur Gargoylosaurus, and the slightly larger bipedal herbivore Camptosaurus. The Morrison Formation, however, was not without its dangers. As herbivores emerged, so did carnivores to feed on them. The plains and forests of the Morrison Formation would have been populated by dinosaurs that were ready and willing to pose a threat to Diplodocus throughout each stage of its life, from the humble beginnings in the forests to the huge migrations out on the plains. In the forests, dinosaurs such as Ornitholestes would have been prepared to snatch up defenseless baby sauropods as they darted into the foliage for cover. Taking larger prey would have been dinosaurs such as the tyrannosauroid Stoxosaurus, whose powerful jaws would have snapped up a juvenile sauropod given the chance. Out on the plains would have lived Diplodocus's most formidable enemies, the theropods Allosaurus and Torvosaurus. Allosaurus, also known as the Lion of the Jurassic, is thought to have been the apex predator of this time and place, and may even have hunted in packs to bring down animals as large as adult Diplodocuses. Elsewhere in the wetlands and forests of the Morrison Formation, a whole host of other animals made their homes. A series of early ray-finned fishes swam alongside frogs and salamanders in the rivers and lakes of early North America, who were in turn preyed upon by early crocodilomorphs, such as the long-legged, forest-dwelling Hoplomachus. Lizards and Sphenodontia scurried through the trees and undergrowth, likely pursued by small theropods eager to catch their next meal, as pterosaurs such as Mesodactylus and Harpactignathus fluttered through the crisp woodland air above after insects. These forests were composed primarily of cycads and ginkgos, as well as tree ferns. Plant life on the ground consisted mainly of horsetails, growing alongside algae, mosses, and fungi. It was a lush world teeming with life. The Diplodocids, and the dinosaurs closely associated with them, were a family of sauropod dinosaurs that first appeared in the Jurassic, but some scientists believe that they may have evolved as early as the Late Triassic period. They died out at the very end of the Cretaceous period 66 million years ago, with the advent of the Chicxulub asteroid impact, the natural disaster that wiped out all of the non-avian dinosaurs. Over the course of the Mesozoic, they were a very successful and widespread group, and the family contains some of the most well-known sauropods of all. The Diplodocids typically possessed very long necks and very long tails, with skulls that were tiny in comparison to the rest of their bodies. They were all quadrupedal, with 4 straight, thick legs that supported the immense weight of these dinosaurs. All of these dinosaurs were herbivorous, able to feed on a variety of plant matter depending on the species, from the tallest treetops to the lowest growing shrubs. Their teeth were typically spatula-shaped, thin at the base and thick at the tip, used for pulling and shredding plant matter from the branches of foliage. All of the Diplodocids were generally large, even for sauropods. In fact, Diplodocus halorum is thought to have been the largest, measuring a possible 30 meters in length from nose to tail. Even the smallest Diplodocid, a dinosaur known as Linecupal laudicauda from the early Cretaceous of Argentina, was 9 meters in length, roughly the same length as 3 African elephants. The Diplodocids were split up into 2 distinct subfamilies of sauropod. On one side sat the Apatosaurinae, the animals that were more closely related to Apatosaurus. On the other sat the Diplodocans, the animals that were more closely related to Diplodocus. The Diplodocans were a diverse group and contained many more genera than their sister subfamily. Notable diplodocans include, as well as Diplodocus and the aforementioned line cupal, Barosaurus, a huge animal from Jurassic Utah, and Supersaurus, an American Late Jurassic giant. Other lesser-known diplodocans populated the rest of the group, including Torniaria from Tanzania, Gallimimus and Catodocus, both found in the Morrison Formation alongside Diplodocus. On the Apatosaurinae side sat just two named genera of dinosaurs, Apatosaurus and Brontosaurus. These dinosaurs were interestingly once thought to belong to the same genus, and Brontosaurus was once thought to have been an obsolete name. Brontosaurus is perhaps one of the most instantly recognizable and well-represented dinosaurs in the media, and Apatosaurus isn't too far behind. Both dinosaurs were massive herbivores that lived in what is now the United States of America in the Late Jurassic period, and to this day remain a staple attraction in museum exhibits across the country. Interestingly, one more diplodocid sits outside both of these subfamilies, an 18-meter-long American sauropod dinosaur known as Amphicoelius. It is a debated genera in terms of classification and has been moved around and experimented with in the fossil record across the years since its initial description in 1878. To this day, Diplodocus and some of its closest relatives remain some of the most iconic and well-known dinosaurs, thanks to their prolific rate of discovery and immense sizes. You would be hard-pressed to pick up a book on dinosaurs and discover that it doesn't have a picture or mention of Diplodocus somewhere in its pages, citing its whip tail that could break the sound barrier, or showing it locked in combat with a hungry pack of Allosaurus. Typically, any record-breaking dinosaur will always capture the hearts and attention of the general public, and Diplodocus's possibility of holding the record of the longest dinosaur ever has no doubt contributed to the cultural success that this awesome animal has carried. All you need to do to see this in action is to look at Dippy, the world-famous Diplodocus specimen that is being transported the world over in natural history museums. Every time the dinosaur was displayed in a museum, it garnered a huge level of interest, with PR teams and marketing efforts supporting the museums to introduce the dinosaur to the world. There's no denying it takes a special place in the fossil record to achieve such a feat.